it's Mr. Emery here, and today I will teach you the final things there is to learn about differentiation further maths, GCSE. So buckle up because this is the last episode, and I don't know. Which means that you would have covered everything there is to do with differentiation. I haven't gone through finding tangents and normals, but you probably know that from normal maths, which will tie into other videos if I'm not lazy. So let's get started with continuing from stationary points. Now you need to see if a gradient function is increasing or decreasing. What that means is if it's going down or it's going up. Some functions are always decreasing or always increasing, or they're funky wonky. So sometimes they have bits that are increasing and decreasing inside the entire graph, and it looks like spaghetti, which is normal. So when it's increasing, a gradient function will be positive, and when it's decreasing, there will be a negative gradient. So let's do an example. Imagine you have, for what values of x is y equals 2x squared plus 12x minus 10, a decreasing function. So it gives it to you in the question that it's going to be decreasing. And how do you know if it's going to be decreasing? When the gradient is less than 0. So let's just differentiate it. dy dx equals 4x plus 12, and just make it less than 0. So 0 is more than 4x plus 12. And solving this gives us x is less than minus 3. So that's our answer. It shows that when x is less than minus 3, our function is decreasing. Yes. Now next, I will teach you whether or not a stationary point is a maximum, a minimum, or a point of inflection. How do you know if it's a maximum? When it's a positive function on the left, it's just stationary in the middle, and it's a negative on the right. That means it's a maximum. So it would look like this. A positive on the left, then our stationary, then our negative, because the gradient is a negative. This is a maximum. Now, now you might be asking, hey, okay, that's pretty good. But like, how do I know when it's a minimum? I will show you. A minimum will have it so that it's negative on the left, it's stationary in the middle, and that it's positive on the right. This will always be it. And for our last one, a point of inflection, it will be that the same sign on both sides. So this will mean it's a point of inflection. So if it's positive, stationary, positive, it's a point of inflection. Or if it's a negative, stationary, negative. This is point of inflection. Yeah, you get me. Now, let's put this into action. Here's a question. The curve y equals 2x to the power of 4 minus 9x squared plus 10 has a stationary point at 3/2 minus 1/8. And the question is asking, determine the nature of the stationary point, giving reasons for your answer. What do you do first? Yes, that's correct. You differentiate. So step 1, oh my god. Step 1, you differentiate. dy over dx equals 8x to the power of 3 minus 18x. Then all you have to do is, we know that this is when it's 0. So it's just 0, the gradient is 0. All we need to do is put values of things that are just to the left and just to the right of 3 over 2. So 3 over 2 is obviously 1.5. So all you need to do is sub in an x value close to each side of the stationary point. For that, it's going to be x equals 1 and x equals 2. Now, why did I do this? Because on a graph, to find the point of inflection, 3 over 2 minus 1/8 is around here. If this was to say 1.5, I will have to put in values of 1 and 2 because they're closely related. So it will show me if it's a minimum or if it's a maximum. So let's do just that. When x equals 1, dy over dx equals 8 minus 18, which equals minus 10. This is obviously less than 0. Then we sub in x equals 2, which means that dy over dx equals 64 minus 36, which is 28, which is obviously more than 0. So what is this? It's negative on the left, positive on the right, which means that obviously 3 over 2 and minus 1/8 is a minimum. We can see this as going down, negative, stationary point, 0, because at stationary point, this is basically when it's 3 over 2. And our maximum, our positive, which will all add up to give you a minimum. You can also check your answer by doing the second derivative. So all you need to do is find the second derivative of this and then see that it's larger than 0, which means it's a minimum. Right, that's it. You've finished everything there is to do with differentiation further maths. Yeah, I don't know why you're watching these videos, because, yeah, I don't know. Goodbye, and do well on your maths, because I can't believe that you would resort to this. You're in such a bad place. But you don't have to be if you revise. So go and revise. Wake up call, like an alarm clock. All right, bye.